So in this video, I want to talk through just kind of a general strategy that you have for solving quadratic equations. So we have four different methods that we can use to solve any kind of quadratic equation. So the first one that you have is to factor. Now factoring is not something you can always do, but if you can factor, it's probably going to be the method that you should use where you make the least mistakes in terms of looking at a polynomial. So you always want to see, can you factor something? And the way you would do that is you would set it to 0 and then look at that non-zero side and see, can I factor that non-zero side using various methods. It may just be that you can factor out a GCF. It may be a trinomial that you can factor into a couple of binomials, or maybe a difference of squares. Those are different kinds of things that we encounter if it's something we can do by factoring. So we always want to check to see, can we factor something? The second method that you have that does not always work, but if it is in a certain form, it is probably going to be the quickest, easiest way you can get there without making mistakes, and that is the square root method. Now, with the square root method, it's got to look a certain way. So you have to be able to get it to where you have some kind of expression squared is equal to a number value. So I'm going to use number sign. So if you can make it look in that way, then we can just hit it with both sides with the square root, put our plus or minus, and get our two solutions. So again, if it looks that way, that's probably the quickest and easiest way that you can get there. So those two methods do not always work, but when they are available to you and you see that you can do that, they are probably the quickest and shortest way that you can get there. The other two methods that you have always work, and that is completing the square, which I found most students avoid completing the square. And so I want to kind of show you with a couple examples of times where I would choose to do something completing the square and when I might choose to do something with the quadratic formula. I mean, the quadratic formula is your standby that if you can make it look like it does up here, so if you can get it to be something that is in this form here, ax squared plus bx plus c equals 0, then yeah, we can just plug it into that general formula that you have, that quadratic formula, that x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And I've found students love that because it's a formula and they can just plug into that formula. And there's nothing wrong with that. It's just that sometimes that formula can be where you make a mistake because there's a lot of steps involved in going through and solving something with the quadratic formula. So I want to look at several examples and just kind of show you what my thought process would be as I go through these and why I choose to do some of these problems the way I do them, and hopefully that will help you moving forward. I mean, even if a problem asks you to solve something with completing the square, if you don't remember the completing the square when you get to that problem, if you can use the quadratic formula, then by all means go and use the quadratic formula. I know there's some specific questions on my math lab where you have to solve it the way they ask you because of the questions that they ask, but don't forget that if you are solving something, you can get your answers by using possibly a different method than maybe what that problem says. So I want to look at some examples and show you advantages and disadvantages. So first here, I want to look at two problems that are very much the same in the way they look. So I have 4x squared equals 32x over here on the left. And on the right over here, I have that 4x squared equals 32. So the only difference is here, this one has an x on the 32, and this one does not have an x on the 32. But the way that I would go about solving these is very, very different. So if I start with this one on the left, so I have an x squared and I have an x. That immediately, from the very beginning, eliminates the fact that I can use my principle of square roots because I have a squared term and I have an x to the first term. So that's out. So what I would do is I would set this to 0 and ask myself, can I factor this? So if I move that 32x over, then I end up with 4x squared minus 32x is all equal to 0. And so now I have a couple of choices. I can see, can I factor it? And if I can't factor it, then I'd have to move on to either using completing the square or doing the quadratic formula. Either one of those would work for me. So where I have 4x squared minus 32x. That I can factor because those are two terms, and those two terms do have something in common. The 4 and the 32 have a common factor of 4, but what's important is the fact that the x squared and then the x, there's a common factor there of x. So I can pull out an x, and that leaves me with x minus 8 inside my parentheses. So I was able to factor that into two factors, and now I can set each one of those factors equal to 0. So I can set 4x, sorry about that. So I can set 4x equal to 0. And however you want to reason through this with yourself, or just go through the steps algebraically, 4 times some number is 0. The only number that's going to be is 0. Or if I divide both sides by 4, I get 0 divided by 4, which gives me 0. So one of my solutions is that x equal to 0. And then x minus 8 equal to 0. That one's very straightforward to solve. That gives me x equal to 8. So those are my two solutions. Now, if you had not seen that you could have taken out that GCF, then you would have had to have used the quadratic formula, and your A would have been 4, your B would have been negative 32, and then there is no constant term, so my C would have been 0. So if I was going to use the quadratic formula, I would have had A was 4, I would have had B was negative 32, and I would have had C was 0, and you could have gone through and used your quadratic formula and gotten those same two solutions once you simplified it. And that's where you would have run into a little bit more of just a simplification process in using the quadratic formula, is that you would have had to do a lot of simplifying to get down to the point that your two solutions were x equal to 0 and x equal to 8. So try to choose the simplest method when possible, unless the problem is specifically asking you to solve it one way, but try to use the simplest method when possible. Over here on the right, what I have is I have 4x squared equal 32. So when I see something like this, and all I have is a squared term equal to a number, then that jumps out to me that I should do that using the principle of square roots. So what I can do is I can get this x squared by itself by dividing both sides of this equation by 4. And that gives me that x squared is equal to 8. And so I was able to get that to be something squared equal to a number. And if I can get it to be something squared equal to a number, then I can solve this by now taking the square root of both sides of this equation. And when I take the square root of both sides of that equation, the square root of x squared gives me x. And then don't forget your plus or minus, because you should get two solutions out of this. And then I have the square root of 8. So x equals plus or minus the square root of 8. Now it's good that you got to that point, but you always want to make sure and look at this radical and ask yourself, can I simplify this? So if possible, you want to simplify what is underneath that radical. And so I can simplify the square root of 8. And so I could write this as x equals plus or minus. The largest perfect square that's a factor of 8 is 4. And so I can write this as 4 times 2. And then this part here is a perfect square. And so I can get that x equals plus or minus 2 times the square root of 2. So those are my two solutions to that equation there. So again, it's looking at the simplest method that you have to go through and solve these quadratic equations. And you couldn't use factoring to solve this equation. It's basically already in the form that you needed in to complete the square. And the quadratic formula, you would have to use a value of 0 for b, and there would be a lot of simplifying that you would have to do to get to this point. So this is the shortest, quickest, easiest method that you have to solve something like this, where you have something squared equal to a number. Okay, let's look at a few more examples here. So we have 3 times x minus 1 squared plus 24 is equal to 0. Every time I give a problem like this on a test or a quiz, I will have students that want to go through and multiply this out. They want to take the x minus 1 times the x minus 1, then distribute the 3, then add the 24, and get it into that different form that you have for quadratic equations. There is absolutely no need to go through and do all that because it's already in the form where it's something squared, and I can get that equal to a number. So first thing that I would need to do is subtract 24 on both sides of this equation. And that would give me that 3 times x minus 1 squared is equal to negative 24. And then I can divide both sides of this equation by 3. So I can divide by 3. I can divide by 3. And that gives me that x minus 1 squared is equal to negative 24 divided by 3, which is going to give me negative 8. So I have it to the point where I have something squared equal to a number. So if you encounter something like this, please don't go through the trouble of multiplying out the x minus 1 and distributing the 3 and doing all that stuff, because then you're going to have to use the quadratic formula or possibly complete the square. It's already in a form for you where in just a couple of steps you'll be able to solve this equation here. So I have something squared equal to a number, so I'm back to the same thing we were just looking at. So now we're going to take the square root of both sides of this equation. So the square root of x minus 1 squared is going to leave me with x minus 1, and that's going to be equal to my plus or minus again. Don't forget your plus or minus. And then the square root of a negative 8. So we already saw from the previous problem that we were just looking at that if we simplify the square root of 8, we're going to end up with 2 square root of 2. So now if all we have is the square root of negative 8, then that's just going to be an imaginary number, a complex number, and so my answer is going to have an I in it, and so we can write it as 2I times the square root of 2. Or if you prefer, you can put 2 square root of 2 and then I. It doesn't matter which form you write it in. I prefer the 2I square root of 2 just because you can tell that that I is not underneath the radical if you write it in that form. So this is going to be plus or minus 2I times the square root of 2. And then my last step, because we always have to solve for x, is I'm going to move this minus 1 over to the other side of my equation. So if I take that negative 1 and move it to the other side of my equation, that's going to become a positive 1. And I'm going to write the plus or minus part last. And so x is going to be equal to 1 plus or minus 2I times the square root of 2. So my two solutions to this equation here are 1 plus 2I times the square root of 2 and 1 minus 2I times the square root of 2. I just wanted to separate that out for you so you can see those two solutions. So again, if it's already something squared equal to a number, you want to use that principle of square roots. That square root property is the quickest, easiest way you can get there. It's going to require less steps, which means less opportunities for you to make a mistake. So please keep that in mind as you're going through and solving those various types of equations. Okay, so now I want to concentrate on some factoring versus completing the square versus quadratic formula. So let's look at x squared plus 10x plus 23 is all equal to 0. So that is a trinomial, and so I can't use principle of square roots, but in looking at that trinomial, I would want to ask myself, could I factor that trinomial into a couple of binomials? And so if that were the situation, I'd have to be able to find two numbers that would multiply to give me positive 23 and add to give me positive 10. And there are not two numbers that I can find that are going to multiply to give me 23 and add to give me 10. So I cannot factor this trinomial. So that's out. So we can't factor it. So now I'm down to really two choices. And that is I can plug all of that into the quadratic formula. And if I were going to plug that into the quadratic formula, then there's an understood 1 in front of that x squared. And so my a would be 1. So my a would be 1. My b would be 10. And my c would be 23. And again, I don't disagree with the fact that now you just plug that into a formula. But the quadratic formula has a lot of steps to it that involve a lot of simplification. So I use that as a last resort. I don't use it unless I just absolutely have to use that because of all the mistakes that I see with students in simplifying underneath that radical. They reduce things when they shouldn't reduce things. So just from a personal standpoint, I try to avoid that simply because I know about all the mistakes that I see on a general basis. So while I could plug it into the quadratic formula, there are certain times when completing the square is probably the easiest. And what you want to look for is you want to look for, is there a 1 in front of this x squared? And so yes, there is a 1 in front of that x squared. So you got to have that first and foremost. And if it's not a 1 there, you could divide everything through and make that a 1. But it has to be a 1 in front of that x squared in order for you to use completing the square. The next thing I look for to determine whether I'm going to complete the square or not is whether this number here can be halved easily. Meaning, am I going to get fractions out of it? And I'm not, because 10 is a nice number that if I halved it would give me a positive 5. So because that number, when I take half of it, is a nice number, then that tells me that probably the quickest way for me to get to my answer and to make the least mistakes would actually be to complete the square in order to solve this. So since I'm going to complete the square, first thing I'm going to do is I'm going to move this number over. After I've made sure there's a 1 there, I'm going to move that 23 over to the other side of my equation. And so this is going to become x squared plus 10x. Leave myself a little bit of room. And that's going to be equal to a positive 23 moved to the other side turns into negative 23. I subtracted 23 on both sides, so that left me with the negative 23. So now, to complete the square, I go back and I look at this number that's in front of x, that 10 right there. And I do a little bit of work on the side over here. And the first thing I do is I half that, or so I multiply it by a half or divide it by 2, however you want to think of that. So I take 10 divided by 2, and that gives me 5, and I'll put the 5 in there. But what I do is after I half it, I turn around and I square it, hence the name completing the square. So half of 10 gives me 5. So I'm going to take 5 and I'm going to square that. And if I take 5 and I square that, 5 times 5 gives me 25. So what I do is I come in here and I add 25 to each side of this equation. So I balance that out. If I add it to the left-hand side, I have to be fair and turn around and add that to the right-hand side. So my goal, basically, in completing the square is to get back to the square root method. So my goal is to get this to be something squared equal to a number. I'm going to go back and use that square root method that I have. So once I've taken that half of that number and squared it, what I'm left with over here is a trinomial that I now should be able to factor. So I should be able to factor that trinomial. So the two numbers that are going to multiply to give me 25 and add to give me 10 are 5 and 5. And so this is going to factor as x plus 5 times x plus 5, which I'm just going to write as x plus 5 squared. So that trinomial that you build over there will always factor as something squared. It's the way you built it. It's why we take half of it and square it, is it builds us a trinomial over there on the left-hand side that we can factor easily. And then over here on the right-hand side, we have negative 23 plus 25, which is going to give me positive 2. And so I have x plus 5 squared is equal to 2. So I am right back to the square root method. And so now what I do is I just finish this off using the square root method. So I take the square root left-hand side, take the square root right-hand side, and that gives me that x plus 5 is equal to plus or minus the square root of 2. So I have x plus 5 equals plus or minus the square root of 2. So now we're just going to move this positive 5 over to the other side of our equation. And so x is going to be equal to, I'm going to write the plus or minus last. So positive 5 moved to the other side is negative 5. So this is negative 5 plus or minus the square root of 2. So my two solutions are negative 5 plus the square root of 2. And my other solution is negative 5 minus the square root of 2. So those are my two solutions. Excuse me. So again, I prefer to do that when that number is there in there. When I take half of it, it becomes a nice number, because then it becomes a pretty short process in terms of taking half of it, squaring it, adding that to both sides, and then just getting it back to where I can use the principle of square roots, which is something you have to already know how to do anyway. So that's just my preference. Now, if you had decided, hey, I don't want to work that problem using completing the square, sorry, then you would have to use the quadratic formula. So I just want to show you with a comparison over here on the right hand side of the screen here. If I chose to do this problem with the quadratic formula, then my A would be 1, as we said a minute ago. My A would be 1, my B would be 10, and my C would be 23. I'd have to go back to where I had it x squared plus 10x plus 23 equals 0. So when I plug that into my formula, x is going to be equal to negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 23. And all that divided by 2 times 1. So yeah, the advantage of the quadratic formula is once you have it memorized, you're just plugging numbers in. And that's a nice thing sometimes when you're going through and working out a problem. But again, you have to be very careful with the quadratic formula, because now with all these problems, there is going to be different levels of simplification that you're going to have to do depending on the numbers that you have. So first thing I have to do is simplify that radical. So it's going to be negative 10 plus or minus the square root of, so I got to follow order operations underneath that radical. So 10 squared would give me 100. And then I have 3 numbers that I'm going to multiply together. So I have 4 times 1 times 23. So 4 times 1 is 4. And then 4 times 23 is going to give me 92. So it's going to be 100 minus 92, all that divided by 2. So watch your signs. This is where you can make mistakes with the quadratic formula. So be real careful about that. So I did 10 squared, which gives me 100, and then 4 times 1 times 23. Multiply those 3 numbers together, gives me 92. And use your calculator if you need to use your calculator to help you with the multiplying and the squaring and things of that nature. There's nothing wrong with that. So this gives me negative 10 plus or minus the square root of 100 minus 92, which gives me 8. All that divided by 2. And then, to me, this is where the quadratic formula becomes a bit of an issue, is that now what I have to do is I have to ask myself, can I simplify this number underneath that radical? So can I simplify the square root of 8? And as we saw with the previous problem, yes, we can. We've simplified square root of 8 a couple of times now. So it's going to be negative 10 plus or minus square root of 8 is 2 square root of 2, all that divided by 2. And so now, because I know what my answer should be. My answer should be negative 5 plus or minus square root of 2. That's what my final answer should be with this problem. So now that I have it in that form, what I have to look at is, does this number here, the negative 10, does that number there, the 2 that is outside of the radical, and does this number down here in the denominator, does that 2? It has to be something that's common to all 3 of those numbers. If you cannot find a number that goes into all 3 of those numbers that I have underlined, then you cannot simplify anymore. It has to be a common factor to all 3 of those numbers every single time. So the only way you can simplify with the quadratic formula is if you're able to simplify the radical, and if you're able to simplify the radical, and you're able to pull a number out from underneath that radical, then the only way you can continue to simplify is if all 3 of those numbers have a common factor. And all 3 of those numbers do have a common factor. They all have a common factor of 2. So I can reduce this to a 1, I can reduce this to a 1, I can reduce this to negative 5. So I can reduce all those by 2. And so I get that x equals negative 5 plus or minus the square root of 2. All that's divided by 1, so it just ends up being negative 5 plus or minus square root of 2, which is the same answer that I got over there using completing the square. So again, it is completely up to you in terms of how you solve. I know sometimes they specifically ask you to solve a certain way, but there are advantages and disadvantages to each different procedure that you have to solve quadratic equations. And no matter what method you use, you're going to have to take your time and you're going to have to be careful along the process, that you simplify when you can simplify, that you use complex numbers when you have square roots of negative numbers, that you don't forget your plus or minuses. So there are many different things that you have to pay attention to when going through and solving these using the various approaches that you have. So I'm not going to work out these last two examples completely, but I just wanted to talk to you about a couple of things related to these. So over here we have 12r squared plus 29r minus 8. So that's a trinomial. And so first and foremost, I would check to see, can you factor that? And that is not going to be something that's going to be quickly and easily factored, because you don't have a 1 in front of that r squared. Sometimes I use different letters other than x. Don't let that bother you. But the fact that that's not a 1 is going to make this a bit of a challenge to go through and factor. But you could sit there and think about all the ways that you can get 12, which would be 1 times 12 and 2 times 6 and 4 times 3. Those would be the different ways that I could get 12. And so you could sit there and you could guess and check, or if someone taught you how to do something using the AC method, you could also use the AC method. But you could sit there and guess and check with your different factors of 12. So you could have to check with r and with 12r, and then you'd also have to check with the 2r and the 6r, and you'd also have to check with the 3r and the 4r. So you'd have to sit there, go through and check that, also with the different ways that you can get 8. And so there's different ways that I can get 8. I can get it with 1 times 8, or I can get it with 4 times 2. So I would have to check all the different combinations that I would have with the different sets of parentheses that I have there using my factors of 12, and check all the different ways with 1 and 8 and 4 and 2. So there's a bunch of combinations that you're going to have to check. And make sure you check it both ways. And what I mean by that is that, for example, if you decide that you're going to put the 1 there and you're going to put the 8 there, because then what you're trying to do is see when I do my FOIL, so when I do my outside and my inside, and whatever I put there for my signs, I've got to get a negative 8, which means my signs would need to be opposite, but I've also got to get a positive 29. So you have to check. So in this situation, I'm not going to go through all these, but if I did the 8r and the 12r, I'd have to see, could I get 29 out of that? And no, I can't get 29 out of that in any way, shape, or form. But what I mean by check it both ways is that just because you checked it with 1 and 8, don't forget that you also are going to have to check it with the 8 being there and the 1 being there. So you've got to check it both ways until you find the one that gives you 29. Okay, now the fact that you have to get a negative 8 tells you that you're going to have a positive and a negative in terms of your signs in there, because the only way you're going to get a negative 8 is if you have a positive times a negative. So there's a bunch of different ways that you could go through and all the different combinations that you have to check. So that would take you some time. But you could eventually find that that actually does factor. And I think the one that works is way down here with the 3r and the 4r. So, depending on where you start and how many different combinations you check, it may take you a while to get to the solution that works. But that does factor. So you could factor that one. If you didn't want to go through all the trouble of factoring, then what you could do is you could plug this into the quadratic formula. But again, you're going to have a lot of simplification, and you're going to have some large numbers, because A is going to be 12, B is going to be 29, and C is going to be negative 8. Okay, so just be careful with your signs and be careful with those numbers. I mean, you're going to need a calculator, obviously, because you're going to have some large numbers there. But that will simplify, and you will get it to the point where you can get the two solutions to that equation. What I would not do in this situation is I would not complete the square. And the reason why I would not complete the square is two things. Number one is there's not a 1 in front of that r squared. There's a 12 in front of that r squared. And so what I'd have to do to make that into a 1 is I would have to go through and divide everything in this equation by 12. So I'd have to divide everything by 12. And while that would give me a 1 there, what it's going to give me are a lot of fractions that I do not want to have to deal with. So in 8/12, I'm going to leave it as 8/12. I know we could reduce that, but what I want you to see is that completing the square is going to be a challenge there, because you're going to take a half of a fraction, which you can do, but it's not going to be pretty in any way, shape, or form. So in that situation, if you wanted to take the time to sit there and see does it factor, then you could. If you didn't want to take the time to sit there and see does it factor, then your best bet is in that situation to use the quadratic formula. But again, there's going to be a lot of simplifying that you have to do. So I hope that helps. You've gone through videos where you've learned all the individual methods that you have for solving. And so I just want to kind of summarize everything for you a little bit there and just show you when you could use some things to your advantage and when you probably have a choice and there's going to be some challenges one way or another depending on whether you try to sit there and try to factor it or just go ahead and use the quadratic formula. But the biggest thing with each one of them is, with the factoring, set it to 0. See if it's something you can quickly and easily factor, that's the best way to do. Square root method, if it's in this form or if you can with a couple of steps algebraically get it into that form, then that is probably going to be your quickest and easiest way to get there. With completing the square, you want to make sure you have a 1 in front of that squared term, and then make sure that when you take half of that coefficient in front of x, or whatever your variable happens to be, make sure that that's a nice number that you can easily half and still be an integer and easily square. But the main thing is just making sure you can easily half it. And then while the quadratic formula is just a nice formula you can plug into, there is a lot of simplifying that you have to do in most cases with the quadratic formula. So while you are free to use that, just be very careful with the simplifying process with the quadratic formula. So I hope that helps you as you are going through and working through your homework, that this video will kind of summarize everything for you.